Hi guys, welcome to my YouTube channel. So today we'll be talking about data structures and algorithm. And so I was scrolling through Leetcode and I saw this challenge. It's called merge sorted array. It's a simple one, yeah, but a lot of persons still find data structures and algorithm very difficult. So I'm going to show you how to solve this problem. Merge sorted arrays, right? So, data structure and algorithm is very important as it helps you with your problem solving skills, right? So, but before we jump into it, if you've not subscribed to our YouTube channel, just go and hit that subscribe button. All right, let's do it right now. Okay, okay, haven't done that. We'll just jump right into it. So let's hit the ground running. Yes. So this is lead code, right? This is the problem. Like I said, is called merge sorted arrays. An algorithm problem is an easy one. So this is what we are meant to do. So let's look at the problem. So you are given two integer arrays, num1 and num2, sorted in no decreasing order, and two integers, m and n, representing the number of elements in nums1 and nums2 respectively. That means the length of num1 is equal to the value of m, and the length of nums2 is equal to the value of n, right? So that's what our problem is. So we have to merge nums1 and nums2 into a single array sorted in no decreasing order. Look at no decreasing order being highlighted, right? Have to take note of that. So the final sorted array should not be returned by the function. So we are not returning the final sorted array. So what are we going to do? Instead, we are going to store the sorted array inside num1. Do you understand now? So to accommodate this, nums1 has length of m plus n. So what that means is that our num1, the length of num1 is m plus n. So let's assume that the value of m is 3 and the value of n is 3. So what that means is that the length of our num1 array is going to be 6. Do you understand now? So where the first m element denotes the element that should be merged and the last n elements are set to 0 and should be ignored, num2 has a length of n. So what that is that also remember that the length of nums1 is nums1 plus nums2. So for you to understand more, so let's look at the example. So this is our input. Is our input. So nums1 is equal to is an array, an integer array. So we have 1, 2, 3. So we have 6 elements inside it. Now take note that the last 3 elements are just zeros. Remember that the default value of an integer is 0, right? So we are just using this 0, this 30, as a placeholder, right, to be able to accommodate the second array. Remember, look at this, our second array, which is num2. It has 3 elements, and you remember that I said that nums1's length is equal to m plus n, right? So we are going to merge, basically lift the element of nums2 and put it inside num1. So we are going to add it where we have these zeros. So these zeros are just placeholders, right, to be able to take in the second arrays by the time we merge it, right? So this is what our output looks like, right? So basically, once we merge it, right, we are going to rearrange them in an orderly manner. So for this example, given this input, so we are expected to have these outputs, an array, arrange properly in this case. 1, 2, 2, 3, 5, 6. So look at the explanation, very important. The arrays we are merging are 1, 2, 3, right? And 2, 5, 6. The result of the merge is 1, 2, 2, 3, 5, 6, with the underlying elements coming from nums1, right? You can see, so we are basically moving nums1 into nums2, right? So these zeros we are having here in the case of our input is just a placeholder to accommodate whatsoever we are going to be inserting into it. Remember, the length is m, which is this guy, the length of the element in nums1, plus n, which is the length of the element in nums2, right? Okay, so in case you didn't get that, right, so let's look at second example, right? This is an input. So we have nums1, which has just one element inside it. So therefore, our m is equal to 1. Do you understand now? That's m, that nums1 is equal to the value of m. Now we have lem2, nums2, right? Which is just an empty integer array. Therefore, n is equal to 0. As also, as I've explained also, nums2 is equal to the value of n. Right, so look at the expected output. So we expected to have an array with just an element, because we are basically going to take 0 and put inside num1, right? And basically, when we merge an empty array inside an array with one element, the result is going to give us this output, right? So there's another example in case you are still don't understand what the problem is. So this is input. In this case, we have num1 equal to an empty array, right? Therefore, m, which is the length of nums1, is equal to 0, and we have nums2 equal to 1, and n is equal to 1. Output is the same thing as the second example, right? We are getting an array with just one element. Now look at the explanation here. The arrays we are merging are an empty array, then an array with just one element. Now the result of the merge is also going to give us an array with just one element. Now look at the notes here. Note that because m is equal to 0, there are no elements in nums1. Yeah, m is equal to 0, so it's just an empty array. So the 0 you have inside here, as you can see here, the 0 is only there to ensure that the merge result can fit into nums1. So like I said earlier, we're just using it as a placeholder, right, to keep that space for us, so that by the time we merge the nums2, which also just have one element, right, it can be able to fit into. So that's the challenge we are about to solve. So I'm going to show you how to solve it in a moment. Okay, so let's look at our constraint, right? So we have num1 length is equal to m plus n. I've already explained this. So the length of nums1 is equal to m plus n, right? And nums2 length is equal to n. So these are constraints. So look at the constraints, right? These are what we have to keep in mind as we're coming up with our algorithm. So follow up. Can you come up with algorithm? Come up with algorithm. So now I'm gonna put that question to you. What do we do? How do we come up with algorithm that can solve this challenge, merge sorted array? Okay, I'm gonna show you now. Let's jump into it. Okay, first, let's write our pseudo code. As you know, coding is 90% thinking, 97% problem solving. Then basically the coding there is just 10%. If you can get your problem solving, your thinking in the right place here, it will be easy for you to actually code out the solution. So let's do a pseudocode. So first, I think we need to iterate iterate through the first arrays, right? So we need to iterate through the first arrays like this one, right? So that we can be able to identify the elements in there, read the elements in there. So once we've done that, the next step we need to take, according to my own thinking, yes, I said I'm going to show you, yeah, there could be better ways or there could be other ways of doing it, but this is how we're going to do it in this tutorial. So we are going to iterate through the, the second array, right? Second array, that is nums2, right? So after iterating through the first array and the second array, so I need to keep a check, right? I need to put a condition to ascertain when I have gotten to the first zero, where we have the first zero, which is a placeholder that will determine where we are going to start merging our secondary into, right? Remember, we have in this example, we have 1, 2, 3, right? So I need to determine when we've gotten to this zero right here, the first zero right here, right? If I can keep track of when we've gotten to this zero, then I will know that upon getting to this first zero, right, that is at index 0, index 1, index 2, and that's at index 3, right? We should start inserting into index 3. So that will lead us to our next step, which is determine with a condition statement when when you've gotten to the first zero, right? So if I can be able to determine that, then basically the next action for me to do is to start inserting the elements of the second array, right? So I'll do start inserting the element of the second array, right? I hope you're following me, right? So once we've done that, basically after inserting all the element, the next thing we are going to do is to then sort the arrays, right? Okay, so we're going to sort the arrays, right? So with this now, we just have to sort the arrays, right? And yeah, that will be all for it. Once we sort the array there, we've been able to solve our problem. Told you it's going to be a simple one, right? And these are pseudocode. So once we follow this pseudocode, right, we are going to get it done. All right, so let's hit the ground running. So it's going to be, so I'm going to use an iteration statement to loop through the array. So you can either use a while loop or a for loop. So for this case, I'm going to use a for loop. So let's do for, so I'll declare for an index, for index equal to 0. So index less than 1 and right, do index plus plus. Okay, so with this, we've been able to iterate through our first array. This is just your standard for loop. Basically, what we're doing is to go through the elements of the arrays, right? At every point after first iteration, we increment the index, then we loop again, iterate the increment the index and loop again. So basically your normal standard for loop, right? So the next thing we are going to do is the second step, which is to iterate through the second array. So I'm going to call this one second index, right? It's going to be a quote. I'm going to assign 0 to it. So I'll say second index less than as nums2 dot length, right? So I'm going to do second index plus plus, right? So again, this is a standard for loop. So we are basically iterating through the second array as well. So now we've been able to we've done our first step, we've done our second step. So now is we need to determine with a condition when we've gotten to the last when we've gotten to the last index of the first element of the first array, right? So so when we get to 0 basically, so with that I'm going to do a conditional statement. So I'm going to say if right index if index is equal to m. Now remember our m is what? Our m is, this is it, our m is an integer. It is the length of our num1. So basically I'm trying to check when we've gotten to this first 0 so that I can start inserting. So that means if we, in this case, if we're using this example, our m is equal to 3. So remember, the index of an array starts with 0. This is a problem most beginners do have. So here will be index 0, index 1, index 2, index 3. So right, so I'm using that m, which is the length, to determine when I've gotten to this 0 here, right? So with that, we've gotten to where we need to start inserting, right? So if we've gotten there, what next do we do? So we say nums1 at index, right? So we are basically going to assign nums2 at the second index, right? So we are going to just assign the value here. So then we increment index, right? Then increment our m. So why are we incrementing our n is that, remember, if after iterating, so our index is going to be 3. So that's when this condition can be true, because for this case, our length of our first array is 3, right? So if on the third iteration, our index becomes 3, then we now compare if index, which is at this point 3, is equal to m, which is 3. So if it becomes true, that's when this part can execute, right? That's when we are going to take the first element of nums2, then insert it into where we have the first 0. So we need to increment the index and also increment m, so that our m in the next iteration will be 4. At the same time, our index will be 4, right? That is the fourth iteration, so that this condition here can still be true. Therefore, this line 11 will also be able to execute. So if we don't increment m and our index increments, right, and becomes 4, this condition will not be true again. Therefore, we will not be able to insert the second element of nums2. right? So that's why we have to increment index and also uh, increment our second element, right? So with that, we basically merge the two arrays. So the next thing we are going to do is to sort the arrays, right? So I'm going to do arrays dot sort, right? So arrays is a class in java.ut, so it has a method called sort. So what this method does is it basically sorts a given arrays orderly, right? So we are going to sort nums one. Remember what we are meant to do. So we are not returning a different array, rather we are just basically taking the first arrays, the second arrays, right, inserting it into the first array and sorting it. So that's basically what we are doing. So this is basically, so we are going to run this code and we hope it compiles without any error. So let's go there. Okay, boom, right? We did it, right? So accepted. So cases, our test cases all passed, right? So this is the input that was given to us in this case, and this is the length, which is 3, and this is the second array, and this is the length of the second array. So this is expected output, and we were able to get exactly the same expected output, right? I told you it's going to be simple, right? I have to keep the logic very simple so that beginners can actually understand. Yeah, there are different ways one can actually implement these, but just have to keep it simple, right? So I'm going to try to submit this to see if there are hidden test cases that we've never considered. So let me hit the submit button. Yeah, boom. We were able to pass all the test cases in here. Okay, so there's something I want to show you. Right, so this is our performance, the performance of this algorithm. So we use 4 41.6 MB in terms of memory to be able to this uh, process this algorithm. So this is where we are, right? This is where we are. So this is where algorithm. So in terms of memory management, we beat 40.25% of other submissions. These are codes. So other persons that submitted, we beat about 40.5% of them in terms of memory management. Yeah, in terms of runtime, we were able to beat 35.56% of other submissions, like people that have attempted to solve this challenge on Leetcode. So I think we did better in memory management. Yeah, we did better in memory management. So we use this is where we use 41% of MB in terms of memory and management. Right. I hope all these tests did add up to our memory. So that's it for today. Like, if you like what you see, right, please subscribe to our channel. We have other stuff, other cool stuff that we are cooking out for you there. So subscribe to our channel. Use the comment section. I want to see your thoughts. I want to hear you say something about this algorithm, right? So like, comment. Yeah, I'll be following on the comment section. Thank you.